And today we're going to be talking about a secure and scalable infrastructure for commercial IoT. Now, last time I gave this presentation, it probably looked something like this. A lot of presentations look something like this. Everything is awesome, nothing to worry about, work with Rigado and all will be well. But this is not the presentation I'm going to give today. Because as we've worked with more and more companies to actually move their IoT pilots and prototypes into production, what we're finding is that in a lot of cases, they get stuck. So today I'm going to talk about how IoT is getting stuck as it moves into production, how we're working to try to get it unstuck with our customers and prospects, and what we're learning from doing that. And a lot of times that means that we're trying to help them go from 1 or 2 locations to tens of thousands of locations, and understanding the types of challenges that you run into when you really deploy IoT at scale. So, what do I mean by IoT is stuck? So specifically what I mean is that commercial IoT is stuck in some very particular ways. And commercial IoT is it's a little different from consumer IoT, and it's also different from industrial IoT. So consumer IoT, we're thinking about things like smart home and wearables, personal monitoring devices, and that's a bit of a different landscape thanks to phones. Phones provide the connectivity and computing that we need for those devices. And on the other end of the spectrum, industrial IoT is a pretty different animal, right? We're thinking about expensive servers, monitoring expensive equipment and expensive factories. You can afford to spend a lot. You can spend a lot on the installation, the maintenance, and the development of those systems. Now, commercial IoT sits somewhere in the middle. And what I mean by commercial IoT are things like smart buildings and connected lighting, tracking important assets, figuring out where people and things are, sensing and monitoring, and even guest experiences like in restaurants and retail. And a lot of those are going into places with carpet. They're going into places that are office buildings, or schools, or restaurants, or hospitals. And these types of applications going into these environments require a different type of infrastructure. You can't rely on people's phones. You need something that's in the ceiling doing that connectivity and computing. But you also can't afford to spend thousands and thousands of dollars on a rack-mounted server to do heavy computing. You need something in every boardroom, or every hospital room, or every classroom. And these are very interesting use cases. These are very ROI-driven, hard dollar use cases that companies are excited about. Oftentimes they come down to getting more revenue by having happier guests that spend more money and order more. You might be reducing operating costs by being able to find important equipment in the hospital and locate it so you don't accidentally buy another one or not be able to serve a patient. You might be improving guest satisfaction in a hospitality setting or providing table service. Or you might be just doing a better job of utilizing the assets and the infrastructure that you have. But despite this great ROI potential, what we see across the board is that most of these efforts get stuck at the pilot stage. So why are they getting stuck, right? They're getting stuck, I would argue, for 3 primary reasons. And the first is the sheer complexity of it all. Who here has launched a pilot or a prototype around IoT? Yeah. Was it complicated? It was very complicated, right? And surprisingly complicated, I think, for companies that are doing it for the first time. First of all, there's the actual physical infrastructure of it all. So what devices are we going to use? How are those devices going to connect to something like a gateway that can collect that information? Then how's that going to connect to the cloud? And what cloud services are we going to use? How do all those things fit together in a way that's integrated? And this is often where companies focus initially on that pilot or prototype. But once you get past the actual technology of it, there's the how do I take that technology and actually put it into all my locations? If I'm talking about 10,000 stores or 20,000 warehouses or 50,000 classrooms, who's going to do the installation? Who's going to do the monitoring and maintenance? What tools do I need to do that at scale? And how's it going to evolve, right? I might be putting infrastructure into a hospital to enable asset tracking, but 5, 7 years down the road, I'm going to want to do lots of things. I might want to help locate staff. I might want to optimize scheduling. I might want to track the usage of consumables. So how am I going to evolve this infrastructure I put in place and make it better over time? And then finally, this doesn't happen all at once. So there's a lot of complexity in how do we go from a prototype that proves this is possible to a pilot where we go test this out in 1 or 2 sites or in a few locations, and then, and this is where a lot of companies get stuck, how do I roll that out in a way that makes economic sense and doesn't create a whole bunch of risk in thousands or tens of thousands or even hundreds of thousands of locations? So we know this is a complex landscape. This is just the kind of discovery process that we go through with customers to try to get our arms around the complexity and figure out how do we keep them from getting stuck there. So that's point number 1. Complexity gets us stuck. The second is just the cost. There are a lot of different things that end up costing money when you get one of these IoT prototypes, especially as it moves toward production. There's the design, both the technical design, but also the experience design and the business case design. What is it we're trying to do and why? There's all the development. We need to do development on the devices. We're going to need to do development on the edge. We're going to need to integrate with cloud applications. We want to use services that are reusable as much as we can. There's that deployment, the installation and configuration we talked about. And then there's the management. So once this is out there, how are you going to monitor it, update it, keep it secure? And the issue here isn't so much that this adds up to so much that the ROI doesn't work out. It's more that the cost is unknown. How do I know how much it's going to cost to install, monitor, and manage something that I've never built before? And if I'm putting in an infrastructure that doesn't look like anything I've built to date. So helping to understand the cost and manage the cost ends up being a big sticking point for a lot of these pilots as they're looking at going out into the real world. And sticking point number 3 is risk. The risk of the unknown, the risk of the security breach, the risk of ending up one of the worst breaches of 2018, right? I mean, this is company ending kind of risk, right? So it's very hard if the risk is unknown for a business owner to sign off on, yeah, let's go ahead and put this in every fast food store we own, or let's roll it out to every warehouse that we operate. Because you can't do that if you think there's even a chance that you're going to end up on the cover. Now, making matters more complicated is that the number of risks and the nature of risks are increasing. So this is something that we track very closely. This is the common vulnerabilities and exploits database. And you can see how it's been going up year after year, and especially in the last couple of years as the number and nature of devices have proliferated. This is a fun and also kind of terrifying database to go roam around for a while. And of the 15,032 exploits that they've been tracking this year alone, do they all apply to a given gateway or Bluetooth router or device? No, not all of them, but some do. And keeping track of which one apply to exactly my stack and the devices and the protocols I'm using and the authentication method that I'm using on my access point, that's a lot to keep track of. And it creates more uncertainty and risk. So those 3 things conspire together, we find, complexity, cost, and risk, to stick a lot of very good ideas at the pilot stage. So here's what we've been doing to try to help companies get unstuck and create pilots and prototypes that they can put into production. So first I should explain where we fit in this picture. So our job here is the gateways. We offer a gateway platform that is particularly tuned for connecting lots of different devices and sensors, deploying applications to that gateway in the form of Linux-contained applications, and then scaling securely so that you can roll it out to lots of places and keep it all managed. The gateway itself is a bit of a Swiss Army knife of connectivity. It has edge compute capability, and then it has some management capabilities I'll talk about. ultimately, to reduce the cost, complexity, and risk, we had to look differently at the role of a gateway. It's not just a bridge, it's not just a place to connect and compute, it's ultimately the infrastructure that makes that rollout possible. And to someone's good question a few minutes ago, it's the infrastructure that needs to tell you what needs help and how to manage and monitor it in a way that's cost effective. So that starts with connectivity flexibility, being able to use Bluetooth 5, Thread, Zigbee, Wi-Fi, proprietary mesh. You're going to need to connect to lots of different devices. And if you're going to roll out to lots of locations and stay relevant for years to come, you're going to need to future-proof in terms of the connectivity you support. So this is a part of something that we've built into the infrastructure to make it possible for companies to roll out with confidence. The second is, and this really gets to that future-proofing and scalability, you're going to run lots of applications on these gateways. You might be going in with just a location application or a sensing application that gathers data and looks for anomalies and chucks it to the cloud. But ultimately, once this is in the ceiling of that hospital room or it's in the ceiling of that boardroom, there are lots of things you can do with it. So how do you look down the road at the ability to run lots of different applications securely and on that infrastructure? And then finally, planning for what is going to be a heterogeneous cloud environment. So it's easier sometimes to bring in a solution that is a single stovepipe from device to edge to cloud. But those tend to be purpose-built, and you tend to need lots of them to achieve one or more business objectives. So embracing the fact that, hey, this is an infrastructure we're going to use with lots of cloud providers, running lots of applications, connecting to lots of devices, is really a more scalable way of looking at the role of that infrastructure. And that's what we set out to do with the gateway itself. The second thing we're doing to help companies get unstuck is solve the monitoring and management problem for them some. This ends up being a big stumbling block as companies are trying to go from what's working in the lab to something that can be deployed and managed in thousands or tens of thousands of locations. And it's not that these are unknown disciplines, right? There's a lot to be inherited here from network management services, but those typically don't exist in these early IoT infrastructures. So what we give companies is a way to monitor gateway status for all my different gateways deployed all over the world in all these locations. What's the CPU load? How many devices and what's the bandwidth of that connectivity? What's the memory usage? How do I know when something isn't scaling correctly? We give them a way to manage updates. Updates are simply a part of life with these IoT infrastructures. It is tempting to think, well, I'll put it out there, hopefully I'll never need to touch it. But if you look back at the 15,000 new exploits that have come out so far this year, you're going to have to touch it. You're going to have to update it. It needs to be kept secure, and it's going to need to be done in a way that doesn't disrupt the things around it. So embracing updates as a way to keep that current from a security perspective, but also to introduce new features. The ability to run multiple applications and extend the functionality requires on an updating mechanism. And finally, we make available security patches to address those common vulnerabilities and exploits. So it's unreasonable to think that every company with a deployed IoT infrastructure needs to track all of that themselves and figure out what pertains to them. We do that work for them. So we, in partnership with Canonical, create patches for common vulnerabilities and exploits that are specific to what we're running on the gateways and what our customers are running on the gateways, and we can deploy those automatically so they can choose when to update their gateways. And that, it turns out, is a big part of making the risk mitigation something that allows for large-scale rollouts. As you get toward the process part of that complexity diagram and away from the technical integration, you start to run in some big questions about fairly mundane sounding things. Well, how are we going to ship it to the location? And when they open it, what's in the box? And how long does it take to set up? And how long does the cable need to be if they're using PoE? And on and on and on. And a part of that is creating gateways that allow for turnkey deployment at very large scale. So the way we're tackling that, and this is a recipe, is that when we build a gateway for a customer, it is born with a secure key and encrypted ID that is specific to that customer and their account in the management console. So that when that gateway is plugged in, no matter where it's plugged in, it could be plugged in the ceiling of a warehouse in Central Europe. When it phones home, it knows, oh, I belong to this customer, I have a secure key, I know I've authenticated, so I know that the update I'm about to get is the right one, and I can automatically provision and configure the gateway. So no one has to put in USB sticks or try to SSH in from a laptop or do any kind of local configuration. They need to come out of the box, ready to run. And then once they're running, we've got that management console on the back end so they can be monitored and updated and managed. We feel like this is really the only way to put together an infrastructure that can be deployed in minutes, not hours or days, over tens of thousands of locations. And really that's what's required when you're going to roll something out at this scale. And then on the subject of security, this is something that really does require starting from the beginning. So we use a secure element at the point of manufacture. We sign all of the applications running on the gateway based on that secure key and encrypted ID. All of the file system and apps are kept encrypted always at the gateway. You can't be putting gateways out into the field that have open ports or SSH enabled. I mean, these things need to be hardened, right? Which requires special management tools in order to deploy applications to them. And then, of course, you need the ability to add those new updates and patches as all those new exploits come out. So this is not an easy thing, but it is a known thing. And so being able to secure the gateways from start to finish is a big part of that approach. And then finally, from a cost mitigation standpoint, we're looking at the actual cost of the gateway differently. Now, all gateways are a little different. You might spend somewhere between $600 to $1,500 for a traditional gateway, but that doesn't include the cost of management and monitoring tools or the team that's going to have to do the patching and updating around that. So we've looked at this whole thing from a subscription standpoint. So ultimately what you want is an infrastructure that's going to be a living, breathing thing, and you don't want to pay a whole lot up front. You want something that can scale as you grow and that is based on the actual infrastructure you have deployed. So we've pegged that at about $100 a year per active gateway. Includes the gateway and the management tools and the patching and the tools to do secure updating, and all that's included. And what we're finding is that that's an easier thing for companies to budget for and plan for and digest when they're doing this across 10, 20, 30,000 locations. So that's a bunch of different ways that we're trying to help companies get unstuck, right? We're trying to make it faster, we're trying to reduce complexity, trying to increase the scalability and security of their solutions, and we're learning a lot from the customers who are taking this approach. You know, we're using our gateways in lots of locations to go from pilot to production. So here's some of what we're learning from these customers. One is that there's particularly strong momentum in certain use cases. So in our world, where we're connecting lots of different sensors, often Bluetooth or low-power wireless sensors to applications in cloud, asset tracking is a very, very strong use case. Control and automation of smart buildings and lighting systems, very, very strong use case. And sensing and monitoring for things like cold chain applications, or to make sure an environment is kept within acceptable limits in transit. These are the use cases that are really unlocking meaningful ROI for companies. The other thing we're learning, though, as we implement these use cases and we help them deploy to lots of locations, is that something really interesting happens when you put a scalable infrastructure into an environment. And I'll use the example of a connected restaurant here. So when our gateways go into a restaurant, there might be the same gateway used for several different of these use cases, right? Some gateways are doing locationing based on beacons so you can do table service. Others are sensing things in the kitchen or in the cold storage to make sure that food safety is maintained. And in some cases, we even have them in the parking lot, so we know when people are coming up to pick up their orders, so you can run out and get them their order faster. So the gateways could be doing lots of different jobs, but the ability to have a common infrastructure and the ability to do updates means you can take sort of an agile approach to that, in this case, smart restaurant, So you don't have to have guessed, 18 months down the road and then rolled everything out and hope it works the way you thought it works, and if not, go back out and start messing with it. You can roll out a common infrastructure with what's effectively a software-defined gateway and an almost phone-like app structure, and you can deploy different applications that take advantage of different sensors and create new revenue streams, create new value propositions, change the way the smart restaurant works. And it sounds obvious because I think those coming from the mobile and the web development world, well, of course this is how you would do it. But bringing that kind of agile development capabilities to the physical world requires this type of infrastructure, and it opens up some exciting opportunities. And ultimately, that gets us to our vision for how this plays out. There's a version of how the IoT is threatening to take shape, which is that every different siloed application is creating its own little stack. Okay, we're going to use these sensors and this gateway to track assets and put it in this database. Okay, next we're going to use these sensors on the fridges, and we're going to use these gateways. I mean, you see where this is going. And that's almost the path of least resistance if you're doing it project by project and asset by asset. What we envision is a shared infrastructure. If you think about this as a secure and scalable infrastructure from the beginning, and you can connect to lots of devices and run multiple applications to get to the cloud, you should be able to have one infrastructure. And that can be a shared infrastructure that's creating value for all the companies using the applications and devices that leverage it. So that's our hope for how we can get companies unstuck and create a secure and shared infrastructure for IoT in the future.